Hi guys, welcome to another episode of my YouTube lesson. In today's video, we are going to be looking at question under chemical kinetics. So today we are going to be looking at how we can prove the unit for the zero order, first order, and second order. So now you all know that the rates and you all know that the reaction rate is directly proportional to the concentration. Like the reaction rate is directly proportional to the concentration. And then anytime we want to find the order of reaction, the order of reaction is always the exponential of its concentration. If you want to solve, so now for the zero order, so now let's begin with the solution. So the first one, which is the zero order of reaction. So if you want to prove for the zero order of reaction, you know that the rate is equal to K in bracket of A. K is the rate constant upon our condition will be raised to power of 0 because we want to prove for the zero order. So we are going to make K as with the formula. So our rate will be upon concentration. And don't forget that anything that is raised to power of 0, anything raised to power of 0 is going to be 1. And the formula for calculating rate, normally rate is always concentration upon time. That's the formula for calculating rates differently. Rate of reaction is concentration over time. So rate will now be equal to concentration upon time divided by 1. This division, because anything is power of 0 is going to give us 1. So we can write the equation as this: rate to be equal to concentration upon time multiplied by 1 all over 1 is still going to be 1. So for this zero order, we need to have concentration upon time. So we can write the units. Concentration can be in molar per second. So this is the unit for the zero order. So for the first order of reaction, the second one, for the first order of reaction, the first order of reaction, you know that the rate should be equal to concentration upon time. We write it, the rate equal to concentration over time, and rate for proving it is going to be K, which is constant concentration. The first order is 1. The order of reaction is 1 here, not 0, because we want to prove for the first order of reaction. So we make K as with the formula. So we are going to have rate upon concentration, because anything raised to power of 1 is still going to be the same number. So now rate be equal to concentration upon time. Concentration upon time. The rate equal to concentration over time multiplied by concentration. This concentration that we have here, divided by concentration over 1. So you can write it again like this: concentration to be equal to, constant equal to concentration over time multiplied by 1 all over concentration. So we can divide our concentration up with the one that is down. So concentration will be equal to 1 over, constant will be equal to 1 upon time now. Be equal to 1 upon time, which is second. So at the end of the day, our K for the first order of reaction is going to be per second. The first one, is for the zero order is molar per second. So for the first order is per second. So let's prove for the second order of reaction. For the second order of reaction, the rate, second order of reaction, the rate will be equal to K multiplied by the concentration. So we're going to put 2 here for the second order of reaction. So by making K as the formula, rate upon concentration. So we are going to have two concentration down. can put it like this. And the rate will be equal to concentration. This one will be concentration over time divided by concentration over 1. So we can have K to be equal to concentration upon time multiplied by 1 whole over this one will be square concentration multiplied by concentration. So this one and this one will cancel out. So K will be equal to 1 upon second multiplied by concentration. So we can write it like this: molar per second, per molar per second. So our for the second order is going to be per molar per second. The rate for the first order is going to be per second, and this one is going to be the first order will be molar per second. So this one will be molar per second. So come to the end of our today's class. So if you enjoy this class, please help me kindly subscribe to my YouTube channel and follow up for more questions. Thank you.